Okay, so today we're going to look at section 6.2, which still covering rules about exponents. We're just going to learn 2 new rules, and we're still going to use the rules we had yesterday. Can anybody summarize the rule from yesterday? Yeah?
If it's multiplication, you add the exponent.
Okay, so we add the exponents when we're multiplying. What's the condition that has to be met, though? Yeah? Exactly. Bases have to be the same. So if you're multiplying powers with the same base, add your exponents. All right, so this is an example of what we're going to do today. Okay, so suppose we had a monomial, such as a cubed, and we took and raised that whole thing. Take a cubed, put it in parentheses, and raise it to the 4th power. Okay? Right, this thing right here is called a power of a power. Sometimes I call it, it's a power raised to a power. Same thing. Right, so we're going to do this one out kind of a long way and maybe see a pattern. Did anybody already know the pattern, what you do with the 3 and the 4?
Guys, what do you see there in that problem? Besides the numbers and the letters?
Parentheses.
What do parentheses mean? Multiply. Okay.
Yep. All right. Well, let's see what we do. So, a cubed to the 4th power. That means you're going to multiply a cubed by itself. How many times? 4 times. Okay, so you would write it just like that. A cubed to the 4th power means what Victor just said. Take a cubed times a cubed 4 times. Now, when you write it like that, it's very similar to a kind of problem we did yesterday. What would a cubed times a cubed times a cubed times a cubed be?
Would it be a 9?
No, not 9th, but close.
I was just doing the first 2.
Oh, the first 2?
Yeah, it's like I thought that's for only the first 2.
Okay, so Caitlin reminded us, what do we do with these exponents when we're multiplying with the same base? Take these and, nice job, we add them up.
Oh,
So,
you don't multiply them?
nope.
Okay.
So 3 plus 3 is 6, plus another 3. 9, plus 3 more gives me 12. Right? So we add up all the exponents and we get a to the 12th. Right? So now that we know the answer is a to the 12th, does anybody think they see what you do with the 3 and the 4 to get a to the 12th? You what? Multiply them, yeah. Okay, so whenever we have a power to a power, that's going to be our rule. Okay, it's not a hard rule. We just have to keep it straight. When do we multiply exponents and when do we add them? Okay, because now we have 2 rules.
On the test, are we going to have to put it out like that?
Nope.
Just multiply?
No.
I just want you to see
Learn
why
the pattern, that's all, Victor.
you're multiplying them. Okay, it seemed like at first nobody was really sure what to do with them, but after showing it out, it seems like people seem to get that. Okay, it's a to the 12th. All right, let's try x to the 5th squared. Okay, writing it out the long way, it means x to the 5th times x to the 5th. But if you use that pattern, anybody think they could tell me what that would be?
That's what she.
Sorry, what did you say, Victor?
X10.
X to the 10th. Any questions on that? So when you say, just make sure you say either x raised to the 10th or x to the 10th or
X to the 10th power.
x to the 10th power, something like that. Yep. If it's squared or if it's to the 2nd or 3rd, you can also say squared or cubed. Yep. Let's try r to the 6th cubed. R to the 6th cubed. Anybody different think they can tell me what that one would be? Yep. Good. R to the 18th. All right, so there's a couple examples. Now we'll write it down on your note sheet so you have it. Okay, and this again is called a power of a power.
Guys, just like we did yesterday, we have the the way it's written out mathematically with different letters, and then we'll have, on the bottom that's covered right now, I'll have you guys write it out.
Sometimes I call it a power to a power.
Yeah,
Same thing.
but you don't have to write this out right now. When we get to the bottom, you will.
And it says basically for any numbers, but right now we're just going to be working with positive integers, but it actually works with negatives as well. If you want to raise a power to a power, just take the two exponents and multiply them together. All right, so to raise a power to a power, multiply the exponents, and you keep the base the same.
That's what you get. You guys have in your sheet to raise a power instead of fill in the rest that's underlined.
And if you start doing this with numbers, the numbers can get pretty big quickly, get very big. So a lot of times if you have to do a problem where it asks you to figure out as a number, we might not write the number out because it would be so big. For example, I'll just show you something on the calculator. Like let's say I did 8 squared, and I raised all of that to the 9th power. Okay, that's just like what we did, power to a power. That's going to be really, really big. What would the answer to that be? Just as an exponent. 8 to the what power? Oh, Logan?
8 to the 18th power?
Yeah, it'd be 8 to the 18th power, which is going to be really, really big, and the calculator is going to try to do it out. And it's so big it can't even fit it on the screen. It puts scientific notation. So most of the time when these numbers start getting really big, we're not going to write out the actual answer. Okay? So this is a number that's 16 digits long. It's pretty long. Hey, any questions on that rule?
You guys already kind of did something like this already.
Okay, Rose, how about c squared to the 5th?
C to the 10.
Yep, c to the 10th. How about Kevin? How about y cubed to the 10th?
Say it again, Ken, it's a little bit louder.
Y equals y30.
Why?
Like
Why
this?
what?
y30?
No.
Okay.
No, to the, you didn't do like
The what?
There you go.
Y to the 30th.
Yep, y to the 30th power. Now, if it's a letter, you'd never do it out anyway because you don't know the letter. Right? So even if it's a number, okay, we'll try one with a number. If we don't have one, I'll make one up. But don't do it out because it gets pretty big. So I don't know if we have one with a number, so I'm going to make one up. We'll do this one and then we'll do one more.
Yeah, guys, just do that one right now. All you get, write it down and then do it real quick. So you get x to the 3rd.
Okay, so Alex, what'd you get? What's x cubed cubed?
I got x to the 9th power.
Good, x to the 9th. Okay, let's try
Yeah, guys, this is going to show this is going to show you with a number. This is how it works.
4 squared to the 5th. Okay. 4 squared to the 5th. What would that be? Yep.
It'd be 4 to the 10th power.
Yep, 4 to the 10th. Okay, which seems like a pretty big number, but actually if you type that one in, it's big, but it's not really that big. 104,000, 1,048,576.
Wait, what
So-
was the question?
It's in the millions, but it's still big enough that we would not write it out. Just leave it as 4 to the 10th. Okay. Any question on that one? All right, let's try this. Okay, so that's our second rule for today.
Are we writing it down?
Yep, you're going to write this one down a little bit.
Where do we write it down?
There'll be a spot when we get to it. We'll let you know in the notes.
Yeah, we're just gonna kind of go, and I think with the examples you guys do with this, I don't think you're gonna need to write it down. I think if you see it, you'll understand it.
Yeah, I don't usually see it.
There's no buffer down.
Yeah, it's okay. You said with the examples, you probably won't.
Yeah, with the examples, you'll understand it. It'll be fine.
Okay, so suppose we take a product such as 2x, okay, which we're going to take something in parentheses and raise it to a power. Okay. What are you doing with the 2 and the x inside the parentheses?
You're going to multiply them both by 3?
Well, just pretend that cubed isn't even there. What are you doing with the 2 and the x? What operation? You're multiplying. 2 times x, all of that, cubed. Do you guys remember the name of what you get when you multiply 2 things together? Like when you add 2 things, you get a sum. When you divide, you get a quotient.
Product.
A product. Okay? This is a product inside the parentheses, and you're raising this product to a power. So, come up with a clever name. It's a power of a product. That's all. Right? You're taking a power of 2 things that are multiplied. That's why we use the word product. Right. How would you write out 2x cubed? What would that mean if you wrote this out without an exponent of 3?
How many times is it getting multiplied? Is 2x getting multiplied together? Someone tell Mr. Hager how to write that out.
You would do 2,
Okay.
you go. You raise your hand. You would do 2x times 2x.
Good. So it means 2x, actually I just wrote it right here. It means 2x times 2x times 2x. All right. And now this is similar to like something you saw in the homework last night. Okay? You have different terms. Sometimes they're not all next to each other. They're kind of spread out. We can combine them. Okay? We have a 2 times a 2 times a 2. Okay? What would that give me? No, not 6, not 12. 8. Yeah, give me 2 times 2.
No, it's not 2 times 3.
2 times 2 times 2 is 8. And then what else do I still have left to multiply? I did 2 times 2 times 2. X times x times x. Right, so when I do it in my head, this is the step I think of in my head. Do 2 times 2 times 2, and then x times x times x. How many times are you multiplying 2 together? 3. How many times are you multiplying the x's together? 3. Okay. Notice that exponent at the beginning. 3. Right? So that is your answer. Okay. In this case, I would say 2 cubed is small enough. We can do that one out. Right? If it was like 2 to the 15th power, that's a little bigger. Probably wouldn't. Okay. What did we say 2 to the 3rd power is? 8. Okay. If the exponent or the power is definitely in your times tables, like 8, yeah, we'll do that one out. Okay. Any questions on that one? All right. How about, anyone think they can tell me what that one is without even me writing out the steps?
Would it be 16x?
16, keep going.
X squared?
Yes, it would be 16x squared. Okay, again, I would say 4 to the 2nd power is small enough. You should do that out. If it was 4 to the 3rd power, yeah, I'd still say that's small enough. But if it starts getting too much bigger, we wouldn't do it out. Okay, any question on that one? All right, So just like we always do, let's summarize it as a rule, and then we'll write it a little more simply. All right, so this is called a power of a product. Okay, I think I already told you that. You take and raise each one of these things to the power. A gets raised to the power, and B gets raised to the power. It's kind of like the distributive property, but you're not multiplying, you're raising to a power. Okay? But if it helps to think of it as like a distributive property, but don't get confused, you're not multiplying. You're raising to a power. All right? So A gets raised to the power, and B gets raised to a power. Okay? Each one of these things in parentheses, the A and the B, those are your factors. Okay? Any two things you multiply together, those are factors. All right? So what do you think? This is kind of a little bit of an extension. But what do you think A times B times C to the x would be? I showed you A times B to the x. A to the x. B to the x. C to the x. Good. Okay. You just do it. If you had 5 things in here, you'd have to do it 5 times. If you had 2, you do it 2. Okay. Just do it for each, however many you have. Right. Any questions on that?
Do something? Do that if you want to.
Right, so Mr. Roy is going to go through a couple of those with you. Be careful with negatives. There's something we have to make sure we remember. Mr. Roy touched on it yesterday.
Guys, like I did in this problem, right? Inside the parentheses, what can I separate? Remember yesterday I said we're going to separate some things so it makes it a little bit easy for us to understand. What can I separate inside those parentheses? What can I
Separate -4 and C.
-4 and a C. I mean, I'm not saying you guys have to do this, but it makes it a little bit easier for me, all right, to separate them. But there's no exponent there with that -4. So what do I need to know if there's no exponent there with that -4? Anybody remember? What exponent's going to be there, even though it's not written?
1.
Yeah, 1. And we can pick any number. We could write any number we want to the first power. We just don't do that, right? Any number you see on a homework that's just a plain number, it has the exponent of 1 with it, all right? So we're going to get 1 here. We're going to get 1 there. You don't have to do that. But if it makes more sense to you to put a 1 with numbers or variables that don't have an exponent, you can do that, all right? This is what I do. I draw just like Mr. Hager said, think of it as the distributive property, right? We're going to bring this power in to this power, all right? So, Mr. McGahee, what's that -4 going to become?
-4 with the exponent of 4.
And we're raising it to that power. If it was like this, like -4
Honestly, it's gonna be.
to the first times -4 to the third, I would get -4 to the fourth.
Oh.
But
So is it gonna be -4 to the 3?
it'll be -4 to the 3, right? I know Mr. Hager said don't think of it this way, but essentially what you're kind of doing is multiplying these small numbers, right? When we raise a power to the power, it's kind of like multiplying. So I'm gonna get -4 to the third power for my first thing. Ariana Dietz, do you think you know what the C will become? Look what happened with the -4, right? I got the same thing going on here. I got a 3 on the outside, 1 on the inside. It became -4 to the third. Now I got a C on the inside, 3 on the outside, 1 on the inside. What's it going to be? C to the third. All right? Again, essentially what you're doing is multiplying the thing that's outside by the thing on the inside. 3 times 1 is 3. Right? That's what you do. When you raise the power to a power, you're multiplying by what's on the outside to the inside. Just like, kind of like the distributive property. All right? So, anything else that I need to simplify? Anything else that I can simplify? -4 to the third power. If I was going to do that on my calculator, what would I need to do? Anybody remember from yesterday? What would I have to do with that -4? Parentheses. All right. Remember, when you punch that into your calculator, make sure you put parentheses around it, or it'll come out incorrectly. Does anybody think they might know, is my answer going to be positive, or is my answer going to be negative?
Negative.
Negative, right? Remember, negative base, odd exponent, negative answer. Negative base, even exponent, positive answer. I did one like that yesterday. Anybody know what this is going to be?
58, negative 58.
No.
Maybe 64, see something?
Negative 64, right? This means -4 times -4 times -4. I'm going to get 16 here times -4. It's going to give me -64. Anybody remember on your, if you have a calculator, like one of those blue ones that I bring up here for tests, what do you hit on that calculator for exponent? Yeah, like Ryan showed me right here, right? The little rooftop. All right, that's what you want to use. So I got -64, C3. Done. Again, like Mr. Hager said, that's a smaller number. Third power, we can do that. Again, but if it's a negative x, if it's a negative base, make sure you put parentheses around it. All right, Jalen, you got that? Sure? You have it written down?
No.
Probably should, huh? Next. Everybody have this one? Everybody go with 2A? Yes, yes. All right, this one. How can I, if you want to separate it, well, what I would do is this. All right, I have a negative here, right? That means I'm going to put a 1 there. All right? I'm going to put a 1 also with my x, because that helps me to know what I'm going to do. All right? So, what's the first thing I'm going to raise to a power? -1 to the what? I'm going to have -1 to the 4th power. Davin, what else am I going to raise to a power?
Y.
Okay. And what's the y going to become? You're not sure? What am I going to do with these two numbers, Davin? 4 and 2. I'll give you a hint. You're not going to add them. Multiply. What do you get? 5 to the 8. Yeah. When you get parentheses, numbers on the outside, just think of it as multiplication. All right. We're going to get y to the 8. We missed one thing. What did we miss? I left a little space there. X to the what, Kev? What's it going to be? X to the 4th. Perfect.
Wait, I'm confused. Where'd you get the, where'd you get the -1 from the
I got the-
-1x?
What I do is, when I see a negative sign, I put a 1 there, so I don't confuse myself. I don't want you to think of this as -x. It's not -x. Right? There's a negative sign there. All right? So I'm going to put a 1. All right? -1 to the 4th power. Is your answer going to be positive? Samantha Adams, is your answer going to be positive, or is your answer going to be negative? Positive, right? We got a negative base. What kind of an exponent? Odd or even? Even. That means it's going to be positive. Positive what? Positive what?
4.
No. What is it? If I was going to write this out, what would it look like?
Oh, it's gonna be +1.
Yep, it's
Oh, yeah.
-1 times -1 times -1 times -1. And I don't care what power you raise 1 to, it's always going to be 1. It could be -1 but it could be 1 to the 915th power. You're still going to get 1. You're multiplying 1 together a bunch of times. Victor?
Tomorrow, are we going to be able to review any of this?
Yeah, in the homework tomorrow night will be all reviewed. All right? So I'm going to get negative 1 times negative 1, 1, negative 1 times negative 1, 1, 1 times 1, 1. You can, when you write your answer, you can put the 1 there, 1 x to the 4th, y to the 8th, or x to the 4th, y to the 8th. You don't have to write it with the 1. You don't have to. You're not wrong if you write it this way, right? But you don't have to have the 1. All right? That one's a little bit tricky because we have the negative. My suggestion is, when you have a negative sign, put a 1 there so you know. All right? And like I said, when you have no exponent, put a 1. All right? So you know that sometimes people forget. All right? So I say put a 1 there. I'll leave this up there for a second.
Why do you write so fast?
How do I write so fast?
Yeah.
I don't know. Huh?
Slow down.
Sorry. I'm writing your face.
Hey, Corey.
I'll give you guys a second to get this written down. Good set? No. Okay, I have one more here. Let's do this. All right. So this one now, we have 2 sets of exponents. All right? Again, I got no exponent with the negative 4, I'm going to put a 1. I got no exponent with the x, I'm going to put a 1. I got no exponent with the 5, I'm going to put a 1. Anybody want to take a shot about that first set of parentheses? What's that going to become? Anybody know? Or write it down. I'll give you guys a second to write it down. But look at that first set of parentheses. When we apply what we learned today, the power to a power, what's it going to become?
Is that a 3 or a 2 next to me?
Up here?
No,
That's a
in the
3.
front.
This is a 3, 2. So, does anybody think they know what this first set of information is going to become? Rose?
-4 to the 3rd power.
Okay.
X.
I'm not going to put the little time symbol because we don't have to.
Yeah.
Just like in a math problem, we have like 2x. We know that means 2 times x. Same thing here. All right? We're not doing anything with that. Anything else there? Mr. Hager's going to put parentheses. Anything else there that I can further simplify? Logan?
Negative 64.
Yeah, negative 64, right? Negative base, odd exponent, answer's going to be negative. Negative 64, x 3. Again,
How do you know it's 64?
Because 4 times negative 4 times negative 4 comes up to negative 60.
negative 4 times negative 4 is 16. Times another negative 4 equals negative 64.
Oh, okay, I got
All right?
it.
And like we said, if you want to on your calculator, all right, put parenthesis, negative 4, end parenthesis, all right, hit the little caret button or little rooftop button, 3, that'll give you your answer. All right? Just like Mr. Hager did right here. But you have to put parentheses. If you don't put parentheses, it's not going to come out correctly. All right? So that's one side of this. I have it simplified. All right? Ryan, you think you can do the other side? Do you think you can handle the 5? What's the 5 going to become if we do power to a power on this side?
3. 5 to the second.
5 to the second. You know how to do it. So I got 5 to the second here. Gage, how about the x's? Yeah, we're doing this one. Ryan just did 5 to the first to the power of 2.
Maybe x to the 4th?
No. Rosie?
It'd be x to the 5th.
Nope.
No?
Kevin? X to the 6th.
Oh,
Remember, think of it as multiplication. All right, Mr. Hager, can I leave parentheses around these? This and this. All right. Now, now we've simplified it to a point, Corey. Now we've simplified it to a point where it looks like what we did yesterday. So like Mr. Hager said at the beginning of the lesson, you're going to have to know some stuff from yesterday to be able to do this. So when I look at this, is there anything there that I can multiply?
oh,
Rosie?
you can multiply the negative 64 by the 5.
The negative 64 and the 5. Is my answer going to be positive or negative?
Negative.
Negative. Logan, you all set?
Yeah.
Okay, buddy. Negative, there we go. We'll do 64 times 5 is 320. Yeah? What? Oh, I'm sorry, we didn't do that yet, my bad. Guys, we didn't simplify this 5 squared yet. I'm sorry. Oh, we simplified 5 squared. What are we going to get? 25. 5 times 5, right? Remember, it's not 5 times 2. It's this number multiplied together that many times.
So
That's
it's
what,
25?
25. Right, Victor. Thanks, buddy. 25x to the 6th. Now I'm good. I know my answer is going to be negative. I'm going to multiply 64 times, or negative 64 times 25. I know my answer is going to be negative. 64 times 25, 1,600. All right, so I multiplied the negative 64 and the 25. Is there anything else there that I can do? Logan?
You add the x to the third and x to the sixth.
Nice. And what would I get?
You get x to the ninth.
X to the 9th. Right? This goes back to what we did yesterday. Right? There's no number on the outside of the parentheses. I already took care of that up here. There's no number on the outside. Now, when I have kind of like combining like terms, this is the same, that's the same. Keep the base. The base is x. Add the little numbers together. All right? So keep the big guy the same. Add the little guys together. That's how I got x to the 9th. That's what we did yesterday. So now we took power to a power, simplified everything, and then got it to like what we did yesterday. All right? So that's doing a little bit of both. All right? Remember, in this case, we're not going to give you crazy numbers like to the 5th power. We'll give you like to the 2nd, 3rd, maybe 4th power. All right, so these numbers don't get too big. Okay? So that one's a little bit more tricky because it took what we learned today and the stuff from yesterday. And we had to simplify it. All right? Good with this? All right, now, somebody tell me, what's the order of operations? What's the little thing we use to figure it out? PEMDAS. Now, in this case, all right, Mr. Hager, I can do what's inside the parentheses here first, correct? Okay, just want to make sure. If I'm following my order of operations, I can do what's in the parentheses first.
You get negative 10.
I'll get negative 10, like Logan just said. Negative 5 times 2, negative 10. I'm going to keep my parentheses. So I took care of what's inside the parentheses. What do I still have?
2.
I still got the 2 on the outside, right?
How should we do 10 times?
Not perfect. Negative 10 times negative 10. I have what kind of base? Positive or negative?
Negative.
Negative base, what kind of exponent?
Positive.
No.
Even.
Even. Negative base, even exponent. That means my answer is going to be positive. Good. Positive what? 100. All right. That's it. You're done. All right. This one's got no number, no variables. do what's in, there'll be one like this on the homework too, all right? Do what's inside, do your multiplication inside the parentheses first, and then you'll apply the exponent, okay? Good?
Yep.
Couple more left, guys. Now, we'll give you something to do on your own. All right.
That's a big one.
If we need to, like I do, this is a 6. Yep. -2, A4, B6, all to the 5th power. I'm going to put a 1 here, just in case. Mr. Gallant, any idea what that -2 is going to become?
-2 to the 5th.
-2 to the 5th. -2 to the 5th power. Michaela, how about the A? Okay,
Oh, I know.
hold on, Rosie.
I can say it?
She said, he said, hold on.
I'm giving her a second, that's all. How about the A? What's the A going to become? Remember, you're not adding those exponents. Not sure? Okay. Rosie? A to the 20th. Remember, you're not, when you think of it as a distributive property, when you have a number on the outside, and like you're doing this, you're doing it to this, you're doing it to this. You're raising it to that power. It's A to the 4th 5 times. That gives you A to the 20th. Right? It's not the best way to think of it, but if you have to, basically what you're doing is multiplying those numbers. Right? Think of it as a distributive property. Right? It's like the backwards distributive property. You get the power on the outside multiplied by the power on the inside. You're not adding them. You only add them when there's no parentheses. Okay.
Oh, wait. That's 6.
That's a 6. B30. Perfect. Now, one more thing. We're almost done. What are we going to take care of? Anything else there I can simplify? Ryan?
The -2 and the 5.
The -2 to the 5th. All right? Now, negative base. What kind of exponent? I know it's positive, but odd. What's that mean I'm going to get? Negative answer.
30,
So-
-32, I think?
Let's see. This means -2 together that many times. 2, 3, 4, 5. All right, so I'm going to get 4. We're going to get 4. We're going to get -2. 4 times 4, guys. 16 times a -2 is going to be -32. There's nothing else I can do with my A to the 20. There's nothing I can do with my B to the 30. The biggest thing, guys, is if those numbers are small enough, we need to simplify. When you have a number with an exponent attached, you need to simplify, like I did here with the -2. You have to simplify it. If you have a calculator, it's even easier. All right? Do we have any more on here? We got one more. All right, guys, take a second. Try this one on your own. 2F. All right, guys, let's do this one real quick. I got a couple more I want you to do after this. All right? So I see people making mistakes doing this. Remember, I said if there's no exponent, what should we put? 1. So what am I going to put a 1 with?
3.
The 3 and the D. All right. Remember, I'm taking this 5 and I'm applying it to everything. This, every power or every exponent inside that parentheses is going to get the 5. All right? So it becomes 3 times, then 1 times 5. C, 2 times 5. D, 1 times 5. Right? I'm applying that 5 to everything that's already on the inside. All right? So my 3 will become what? Somebody tell me, what's the 3 going to become? What power? 3 to the 5th. 1 times 5 is 5. Even though it's a number, you still have to apply the power that's on the outside. Gage, what's my C going to become?
No, 5.
I wrote it out here. C, 2 times 5. 10. And then, Davin, how about my D? Good. Now, did anybody get, I'm almost done. I got to do one more thing. What do I have to simplify? 3 to the 5th. If I have a number to a power, I can simplify that. I can't simplify a variable to a power. There's nothing more I can do. But when I have a number to a power, all right, I have to simplify that. What did you guys get when you did that? 243, right? 243, C to the 10th, D to the 5th. Remember, you're multiplying every power by the power that's on the outside. It's like the distributive property. All right? So your final answer should have been 243, C to the 10th, D to the 5th. All right? Guys, I got a couple more practice problems I want you to do before I give you the homework. All right? There's a couple from today and a couple from tomorrow. Homework, I think it's 10 problems. The first 6 or 7, like what we did today. The last 3 are a review of Monday's stuff. And we put right on there from Monday's class, so you'll know.
Bless you.
Remember, test on Thursday. You'll get a reference sheet tomorrow night you can fill out. Obviously, use on the test on Thursday. Friday, we'll do, hopefully, everyone will be done the test. We'll do MCAS open response. If you finish in class, you'll have no homework.